Hey everyone, and welcome. Today we are diving into a piece of tech that's kind of like a private tunnel built right through the middle of the internet's public highway. It's called Generic Routing Encapsulation, or GRE for short. And it's one of those foundational protocols that just quietly makes so much of our modern networking actually work. So let's get into it.
So picture this, because it's a super common problem. You've got an office in New York and another one in London, and they need to talk to each other like they're plugged into the same wall, right? Sharing files, accessing servers, the whole deal. But what's between them? The massive, public, kind of wild internet. So how in the world do you build a private, stable bridge across that public chaos? Well, that's the exact puzzle we're going to solve today.
And here's our game plan. First, we'll really define the networking challenge we're up against. Then, we'll see how GRE's virtual tunnel is the answer. After that, we'll look at where you'd actually use this stuff. We'll break down the beautifully simple four-step process of how it all works. And finally, we'll boil it all down to its one single core function.
Okay, so let's really nail down the challenge. We've got two private networks. They are physically miles and miles apart, but for all intents and purposes, they need to act as one single network. The real problem is creating a logical bridge over a public space, basically tricking all the computers into thinking they have a direct private wire connecting them.
And this is where GRE comes in. It's the solution. What it does is create what we call a virtual tunnel, and it's such an elegant idea. It basically fools the two networks into believing they have a totally private point-to-point link running between them. All right, so here's the official textbook definition. And the key word, the most important word, is right there in the name: encapsulation. GRE, which was developed by Cisco, its whole job is to take data packets, of almost any kind by the way, and just wrap them up inside a standard IP package before sending them across the network. This whole wrapping process is what creates that virtual link. The absolute best way to visualize this is to imagine a private tunnel built for just one person's car running straight through the middle of a super busy city. That car doesn't have to deal with traffic or stoplights or any other cars. It's a straight shot. Well, GRE does exactly that for your data. It carves out an exclusive, direct path right across the messy, chaotic public internet.
So, okay, we know what GRE does. But where do network engineers actually use this thing in the real world? Its versatility is probably its biggest strength, and that leads to some really specific and powerful applications.
This right here shows you just how flexible GRE really is. I mean, sure, connecting remote offices is the classic example, but it's also used to carry traffic that the regular internet doesn't really understand, like multicast streams for video conferences. It also solves this huge problem for routing protocols that need a direct neighbor to even work. And here's the kicker. GRE itself doesn't encrypt anything. It's just a wrapper. That makes it the perfect foundation for a VPN, where you then layer on another protocol like IPsec to handle all the security.
Okay, so we know the what and the why. But how does it actually do this encapsulation magic? Well, it's a beautifully logical, totally straightforward four-step process.
Here it is, the 4 stages of any GRE packet's journey. You can really just think of it like an assembly line. Create it, wrap it, ship it, and then unwrap it. We're going to walk through each of these steps so you can see exactly what's happening under the hood.
And to make this crystal clear, let's use an analogy. Let's pretend your data is a private letter you need to send. The internet? That's the huge global postal system. GRE is like the super specialized packaging service that makes sure your letter gets exactly where it needs to go, untouched. So, step 1, we have the original packet. In our analogy, this is the letter itself. It has the message, the payload, and its own private source and destination addresses. But here's the thing. At this point, the public postal system, the internet, wouldn't know what to do with it. It's unroutable.
Now for the magic. Step 2, encapsulation. This is the wrapping process. Look at what happens. 2 new layers get added on top of our original letter. First, a GRE header gets slapped on. Think of this as an internal memo, telling the receiving mailroom what kind of letter is inside. Then, the whole thing, the letter and the memo, gets put inside a brand new shipping box. This box gets a completely new address label. The from is our tunnel entrance, and the to is our tunnel exit. So, once it's all wrapped up, it's ready for step 3, transmission. And here's the really clever part. The postal workers, the internet routers, they only read that outer address label on the shipping box. They just move the box from one point to another, from one tunnel endpoint to the other. They have absolutely no idea what's inside.
Finally, the package arrives at its destination, the end of the tunnel.
And here, in step 4, the router does the exact reverse process, decapsulation. It rips off the outer shipping box, that's the outer IP header. Then it reads and removes the internal memo, that's the GRE header. And what's left? The original untouched letter, ready to be delivered to its final destination on the private network. The journey is complete.
So now that we've seen that whole process from start to finish, what's the one thing you really need to remember about GRE? Let's zoom out and boil it down to its most basic idea.
At its heart, GRE's power is just its beautiful simplicity. It's a wrapper. That's it. Its genius is that it can take just about any kind of data, stick it in a standard box, an IP package, and send it on its way. This simple act of wrapping one protocol inside another is what lets us completely ignore physical boundaries and build these incredibly powerful virtual direct links.
And that really just leaves us with one final thought. GRE by itself doesn't do any encryption, it's just a transport tool. So in today's world where we're all so focused on security, why is a simple tool like this still so incredibly important? Well, its role as that foundational layer, the thing you build on top of, proves that sometimes the most elegant and simple solutions are the ones that last the longest. Thanks for watching.